Hello and welcome to Electro Nerds Academy. In this video, we will be connecting a buzzer with our Arduino board. Here's what a buzzer looks like. If you have our Arduino kit, you'll find one inside. This kit includes all the essential components you need to start your Arduino journey. If you don't have it yet, check out the purchase link in the video description. Now, back to our topic. A buzzer is an electronic component that converts electrical signals from an Arduino or any other source into audible sound. The type of buzzer we're using is called a piezo buzzer because it relies on a piezoelectric element to function. A piezoelectric element is a material that changes shape when an electric current is applied to it. In our buzzer, this element is attached to a thin metallic sheet and is electrically connected to a small oscillator circuit, which provides oscillating electric current to it. When we apply the rated voltage across the buzzer leads, the oscillator generates an alternating electrical signal, causing the piezoelectric element to rapidly vibrate. These vibrations produce sound waves, which we hear as the buzzer's output. Operating a buzzer is similar to adding an LED in that you control it through one of the Arduino's digital pins. Observing the polarity markings on the buzzer's top, we connect its positive leg to digital pin 8 on the Arduino, while the negative leg is linked to the Arduino's ground pin. Now, transitioning to the software aspect, we will use the same sketch that we used in the previous video, but we will have to modify the pin number within the pinMode and digitalWrite functions to align with the buzzer's connection to digital pin 8 on the Arduino, while the rest of the code remains unchanged. Upon successful upload of the code to the Arduino board, we're met with a distinct, high-pitched beeping sound, characterized by intervals of approximately 1 second. We can also change the sound of the buzzer by adjusting the frequency of vibration of the piezoelectric element. For example, we can lower the pitch like this, or even create a melody like this. All of this is possible simply by modifying the vibration frequency. To do this, we'll use a built-in Arduino function called tone. This function generates precise tones by producing square waves of a specified frequency on a designated pin. The tone function accepts 2 or 3 parameters. The first parameter specifies the Arduino pin responsible for generating the tone, whether digital or analog. The second parameter defines the tone's frequency, ranging from 31 Hz to 65,535 Hz. The third optional parameter determines how long the tone should play in milliseconds. If omitted, the tone continues indefinitely until stopped. We can also stop the tone by calling the noTone function, which requires a single parameter, the Arduino pin number, where tone generation should cease. Now let's see the tone function in action by experimenting with different frequencies. First, we'll clear all the code from the void loop section. Then, we'll call the tone function. Since our buzzer is connected to pin 8 of the Arduino, we'll set 8 as the first parameter. For the second parameter, we'll generate a sound at 100 Hz by writing 100. After uploading the code to our Arduino, let's listen to the sound it produces. Now, let's increase the frequency to 10,000 Hz. Upload the program again and hear the difference. The sound is now much higher in pitch. This demonstrates that higher frequencies produce higher pitched sounds, while lower frequencies result in lower pitched sounds. As mentioned earlier, we can also create melodies using the tone function. We've already written code that plays 8 different frequencies, each corresponding to a musical note. At first glance, the code may seem lengthy and complex, but it's actually quite simple. We start with the setup function, where we set pin 8 as an output pin using the pinMode function. In the loop function, we first have a 400 millisecond delay, then we call the tone function on pin 8 to generate a 262 Hz tone for 850 milliseconds. After that, we have another 850 millisecond delay. We then repeat the process for the remaining 7 tones, changing the frequency each time. Upload this sketch to your Arduino board and see if you can recognize the melody. You can modify the frequencies to play your own tune or add more tone statements to extend the melody. Now, let's go over some limitations of the tone function. Firstly, this function can only generate sound on only one pin at a time. For example, If a 262 Hz tone is being played on pin 8, we cannot generate the same frequency on pin 10 simultaneously. To switch the tone to pin 10, we must first stop the previous tone using the noTone function. Second, the tone function cannot generate frequencies below 31 Hz, as previously mentioned. Finally, while using the tone function, we cannot use the analog write function on pins 3 and 11 because both functions rely on the same timer. We'll explore analog write in detail in the upcoming lessons. That wraps up this video. For more tutorials like this, be sure to visit our channel. You'll find the source code linked in the description below. And as always, don't forget to like, share, and subscribe. We'll see you in the next one.